Ladies and gentlemen, welcome to the Chapter 2 notes for your Pearson Trigonometry textbook. This is for Section 2-1 entitled Trigonometric Functions of Acute Angles. This particular video will cover the first 3 slides of the blank note packet from class. We will be discussing information you should already know from previous classes based on right triangles. So, the section itself is entitled Trigonometric Functions of Acute Angles. Now we should know from a previous section that acute angles are angles less than 90 degrees. So in terms of the big picture, what we're talking about is we're talking about angles that terminate in quadrant 1. Now we're going to be using that same basic idea that we've been using. That is that the vertex of our angle will be at the origin, and that the terminal side will pass through the point xy, which would result in a right triangle with legs of x and y units and a hypotenuse of r units. Our angle itself would end up being the acute angle between the terminal side of our angle in standard position and the positive x-axis, which is where the initial side of our angle is located. So in other words, we're dealing with a right triangle here. Let's get a right triangle drawn, where we are discussing this acute angle here, angle theta. But for purposes of naming, what we're going to do is we're going to start referring to that as angle A. Okay, so we're going to think of it more in terms of it being a right triangle where we have a name for each vertex, so we refer to it like we did in geometry class. Angle A, angle B, and the right angle is angle C. We also know that AB, this side, is the hypotenuse of that right triangle. It is always the hypotenuse, which we will abbreviate HYP. So the difficulty with Sohcahtoa, the difficulty with right triangle trigonometry for most students is that they have a really hard time figuring out which leg of the right triangle is supposed to be the opposite side and which leg of the right triangle is supposed to be the adjacent side. And the problem with that is it depends on which angle we're talking about. If we're talking about angle A, then the opposite side would be the side across the triangle, meaning that side BC would be our opposite side for angle A, which we will abbreviate OPP. And the side right next to angle A, the one that is actually one of the sides of angle A, is our adjacent side. Which we are going to abbreviate ADJ for adjacent. Now on the surface that's not very difficult, but where the problem arises is when we throw in the fact that we could also name the triangle based on angle B. If we name the triangle based on angle B, then AC would be the opposite side. Meaning that would be our opposite. And BC would be our adjacent side. Again, we're going to be abbreviating that ADJ. So that's kind of the difficulty here. Is the naming. And I will say that in my experience as a 13-year teacher, 90% of all issues that students have, roughly, with right triangle trigonometry stem from the fact that they get the opposite and the adjacent sides backwards when they're working a problem. And again, the naming is entirely based on which angle, A or B, we're dealing with. We will never write Sohcahtoa for the right angle. It's always one of the two acute angles, either A or B. So what am I talking about when I say Sohcahtoa? Well, here's our triangle. Let's say we're referring only to angle A. If we're referring to angle A, then BC is our opposite side, and AC is our adjacent side. And of course, AB is our hypotenuse. Well, in geometry, we teach kids, sometimes Algebra 1, definitely by the end of Algebra 2, everyone should have seen the mnemonic to remember the definitions for sine, cosine, and tangent. And that is Sohcahtoa. Now, I've never been a fan of writing it that way. I like to write it Sohcahtoa. And the reason for that is, by definition, the sine of A is the opposite side over the hypotenuse. The cosine of angle A is adjacent over hypotenuse. And the tangent of angle A is opposite over adjacent. So when you see Sohcahtoa, what you're seeing there is the first letter of each of those items. So, Toa. So each piece of that, Sohcahtoa, is representing one of your three basic trigonometric functions, sine, cosine, and tangent. So when you see this, you have sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So by remembering Sohcahtoa, it's supposed to help you remember all three of your trigonometric functions for a right triangle. So, let's use Sohcahtoa, and let's write out the sine, cosine, and tangent for both angles A and B in this right triangle. So we'll start with angle A. We're basically going to do this twice. So for angle A, 25 is the hypotenuse, always. And for angle A, 7 is our opposite, and 24 is our adjacent. So, what we do is we have our mnemonic device, Sohcahtoa, and we use it here. So we have sine is with the blue labels for sine of A. Sine is opposite over hypotenuse. So we do opposite, 7, over hypotenuse, 25. And then, if possible, we reduce, but it doesn't reduce. Cosine of A would be adjacent, 24, over hypotenuse, 25. And tangent would be opposite over adjacent, 7 over 24. It really should be that straightforward and that simple. We should just be using what we know and our labels to write out those fractions. Now, if those fractions can be reduced, they must be reduced. If they, for instance, have a root in the denominator, they must be rationalized. Just like in Chapter 1, our answer has to be in proper notation and should be in simplest form. So, then we move our attention to B. Well, when we change our attention from angle A to angle B, what that does, we still have a hypotenuse of 25. That does not change. What does change is that 24 is our opposite for angle B, and 7 is our adjacent. So when we go to do Sohcahtoa, the sine of angle B would be opposite, 24, over hypotenuse, 25. The cosine of angle B would be adjacent, 7, over the hypotenuse, 25. And the tangent would be the opposite, 24, over the adjacent, 7, 24 over 7. Now you should see some relationships there between the sine, cosine, and tangent of A and the sine, cosine, and tangent of B. Those relationships will be pointed out in the next video, and we will discuss how they relate to each other. So that does it for video 1.